All right, let's go ahead and continue in Chapter 2. I know you're so excited about doing science videos, so just try to control it, right? I'm sure all of you at home are just ecstatic about this. So let's go ahead and get it finished so that you can get to what you want to do. Now, let's talk about derived units. The last video talked about units. Now we need to talk about derived units. This is when you have a unit that is defined by combining two other units. So let's look and see what we're talking about. Some examples. Speed is meters per second. So that's when you take two units, the meters and the second, and put them together. Volume. For solid objects, you have centimeters cubed. So that's, you're putting centimeters together 3 different times. So this was only one type of unit, but you have centimeters times centimeters times centimeters. And the reason our volume is centimeters cubed is because if you'll remember, to get volume, we do length times width times height. So it's centimeters times centimeters times centimeters. Now, if you have a liquid object, you use liters. Now that in itself is not a derived unit, but I just wanted to make sure you knew that solid objects were going to be centimeters cubed, liquid objects were going to be liters or milliliters. But you do need to know down here that 1 milliliter equals 1 centimeters cubed. You need to realize that those can be used back and forth. And then 1 liter equals 1 decimeter cubed. So please know those two equalities so that you're not confused if we switch that up every once in a while. Now, another example is density. Solid objects, when we calculate density, and we haven't done that yet, but you do mass divided by volume. So you have your mass unit here, grams, divided by volume, centimeters cubed, because our volume is centimeters cubed. So once you calculate those, then your ending units and derived units is grams over centimeters cubed. And I'll show you why in just a few minutes when we do practice. Now, liquid objects are going to be measured volume in milliliters. So liquid objects are going to have the mass of grams, the volume of milliliter. You're going to divide those and you get grams per milliliter. And whenever we have the division symbol, we always say per in science, like grams per milliliter, grams per centimeters cubed. Now, to calculate density, we're going to use this formula. Density equals mass divided by volume. And if you have a hard time rearranging equations, I'm going to teach you a trick. Because if you are given density and mass and have to find volume, then you have to rearrange that equation. But if you're not comfortable with that, like I said, watch this trick. Oh, and when you're calculating math problems in chemistry, you have to show your work. If you don't show your work and you just give me an answer, you do not get credit. So make sure you show me the steps that you go through. Now, we're going to start with a circle. This is the circle down here, and this will work with any equation that you need. Even if you need it in math or whatever, you can use this system. So what you do is you look over here, and you always start with the variables on the side that has the most variables. These right here, we have density as one variable, mass is a variable, and volume is a variable. So mass and volume, there are 2 variables on this side, so we need to place those first. And in this equation, mass and volume are over one another, so you need to put them over one another in the circle. There you go. Now you could have put the V on the other side if you wanted to, no big deal. Either way is fine. So then whatever box is left over, you use the unit that is equals to. So then you put D. Now the way the circle works, if I need to find mass, I cover up mass with like my finger or my hand or something, and it gives me the equation. So I cover up mass if I need it. So M equals, and then it has D and V, but they're next to each other. So that means you multiply them together. So mass equals D times V. If you need to find volume, then you would cover this one up with your finger or hand, and it would give you that you have mass divided by density, and that's how you would find volume. All right, so let's look at some examples. All right. What I'd like you to do is I would like you to pause the tape, and then we're going to come back and look at the answers together. So pause the tape where you can still see these questions. Go ahead and work them out on your paper to see if you can then get the right answers, and then resume the tape or the video once you're ready. All right, so here's our circle. I've forgotten to put it up. I apologize. Now, the very first thing we're going to do, it asks us to find density. It says, what is the density? So we know our formula is going to have the D equals M over V, because whatever they're asking you to find would start the formula off. So now, let's go ahead and fill in our formula. So D equals, the mass was 9.17 grams. The volume was 10 centimeters cubed. And we put those over one another because we're going to divide them. Once you divide them, you get that the density equals 0.917 grams per centimeters cubed. If you didn't get that right, make sure you put a little question mark or something next to it so you know to ask me in class. Now let's look at our second question. What is the volume of a sample that has a mass of 20 grams and a density of 4 grams per milliliter? So remember, if we're finding volume, cover up the volume with your hand, and that tells us that we have to do mass divided by density. So our formula we write first, then we can fill in our formula with the numbers we already know, which is 20 grams divided by 4 grams per milliliter, and then you have 5 milliliters. All right? Now, the way we know what our units are here, if you can just memorize them. You can memorize that volume is milliliters or centimeters cubed, density is always grams per centimeters cubed or grams per milliliter, and mass is always grams. You can memorize them or just use your formulas to figure those out. Now, let's look at scientific notation. This should all be a review. Y'all should have covered this in physical science, but let's go ahead and review some. Writing in scientific notation. We use scientific notation to help reduce the number of zeros in very large or very small numbers, either way. And there are some steps in writing in scientific notation. Make sure you jot these down. Number 1, place the new decimal to the right of the first non-zero number. And we're going to do some practice, so don't panic. Second step is count the jumps from the new decimal to the old decimal. Step 3 is write the new number with times 10 after it. And number 4, add your exponent. And the reason we write the new number with times 10 after it is because as we're moving decimal places, it's always moving it by a power of 10, like we talked about yesterday. So let's go ahead and practice. All right, the first step is to place the new and old decimal. Now the new decimal always comes to the right of the first non-zero number. So let's look at our first example up here. I'm going to place my new decimal. That's going to be where my new one is. Now listen, I didn't give you your old decimal. And if I don't give you an old decimal, then we know it always goes at the end. So this is my old decimal. So we'll put N for new, and this one's O for old, because you always count new to old. That's going to be a very important thing in just a second as I show you. And before we talk about that, let's go ahead. Y'all remember number lines in math? So like here's 0. To the right side of the number line, we have positive numbers. To the left, we have negative. We're going to use that in just a moment. So let's go ahead and let's count our jumps from new to old. 1, 2, 3, 4, 5, and 6. So I have 6 jumps to the right. Now I need to place my new number, so I write 5.32. You can leave off the zeros, and it always says do times 10, because every time we jump a decimal place, it's always by a power of 10, so we have to tell how many powers of 10 we jumped. Now, if I'm moving to the right on the number line, that means I have a positive 6 as the power. So this is the answer, 5.32 times 10 to the 6. Let's go down to this next example. Let's put our new decimal. Here's our new one, and we'll put an N so we remember. This decimal is already given to us, the old one, so the old one's there. You always count new to old, so we say 1, 2, 3, 4, 5, and 6. I really didn't mean to make it equal, but 6 jumps to the left. So we write our number, our new number, with times 10 behind it, and then we figure out if we went left on the number line, left means negative, so we went negative 6, and that tells us that we need to move to the left. Okay. Now we also need to be able to do it the opposite way. Like if I give you scientific notation, you need to be able to give me the original number. And give me a second as I erase. So, and you just basically do the steps backwards when that happens. So let's see if we had 3.23 times 10 to the fourth. All right, I'm going to write my 3.23 down here so I have it by itself. This, remember, was my new decimal. Okay, and I've got a positive 4, so that means I need to move to the right 1, 2, 3, 4 spaces. This is going to be my old decimal. So the original number was 32,300. Okay, now let's go do another example going backwards. If we have 2.04 times 10 to the negative 2, I'll put my 2.04 down here. Now remember, this was our new decimal, so that's our new, and the negative 2 tells me I need to go back to my old decimal. I have to go to the left 2 times. And you fill in empty spots with 0. So the original number here was this. All right? Now I'm going to let you do some practice on your own. So go ahead and pause the video and go ahead and work these out on your notes to see if you make sure you understand it, and then you can resume the video to check your answers. All right, here are the answers, so go ahead and check, and if you have any questions, make sure you write them down so that we know in class to go over them. Now, using scientific notation, sometimes you'll have numbers that are in scientific notation and you need to add or subtract them. And in order to add or subtract numbers that are already in scientific notation, the exponents have to be the same, okay? Just like I can't add 5 grams and 10 meters because the units are different. Same thing here, the powers have to be the same also. So I want you to practice. I want you to add these numbers together. Thankfully, you have the same powers. So go ahead and do both of these. Pause the tape while you work on them, and then resume the tape once you're ready for the answers. All right, let's go ahead and look at these answers. Now, all you had to do was say 1.3 plus 7.3, that's 8.6, and then you keep the same power of 10. Because since it started with 10 to the second, you're going to keep 10 to the second. Same thing with the subtraction, 7.7 minus 6.43, that equals 1.27, and then keep 10 to the third power. And there's one more, or two more things that we need to talk about in using this. Multiplying, when you're multiplying two numbers that are in scientific notation, then you add the powers of 10 together. So let me show you what I'm talking about. All right, here's a problem for us to practice with. We have 2.1 times 10 to the second times 1.3 times 10 to the fourth. So what you do is the first thing, you just multiply these together, and that's going to give you 2.73. Now, you cannot leave off the powers. If you start with powers, you've got to end with powers. And what you do is you add these exponents. So we say 2 plus 4 equals 6. So my answer is 2.73 times 10 to the 6th power. Now let me go ahead and talk to you about dividing these numbers also. Even though we haven't put that on our notes yet, let's go ahead and do that. If we have, we'll do the same ones. I'll change the exponents a little bit. So if I have 2.1 times 10 to the fourth divided by 1.3 times 10 to the second. Now you do the same thing. You're going to take the 2.1, divide it by 1.3, and that's going to give you 1.62. Then you still have to have powers of 10 since you started with powers of 10, but you just subtract them. So you say 4 minus 2 equals 10 to the second power. So now let's go back and do our notes on division. Okay, so just like we just looked at, when you're dividing two numbers that are in scientific notation, you subtract the powers of 10. Now, let's go ahead, and I'm going to let you practice again. So go ahead and pause the video, do these two problems quickly, and then resume the video to check your answers. All right, here are the answers. So check those. If you didn't get them right, let me know in class so that we can work on it a little bit more. That finishes our video for the evening. For your summary tonight, I would like you to do a graphic organizer. You can do any type of graphic organizer you would like. You can make up one. You can use one you've done previously in any classes, but somehow organize the information you learned today in a graphic organizer, and I'll see you in class.